Hi friends, this is again your Virat Kumar, lecturer in electrical and electronics engineering. Yesterday, in the previous session, we have seen about engineering curves of involute. We have seen about involute. Today, we will see about the cycloid in the engineering curves. See, in cycloid, we have again five methods in it. First one is general cycloid, second one is trochoid, nothing but superior cycloid, third one is also trochoid, that is inferior cycloid, fourth one epicycloid, and fifth one is hypocycloid. So we will see all these one by one. Before that, we will just know about the definition of a cycloid. It is the locus of a point on the periphery of a circle which rolls on a straight line path. A cycloid, it is the locus of a point on the periphery of a circle which rolls on a straight line path. So directly, yesterday we have seen all these, see involute, this one, this, all this, and today we will directly step into the cycloid. Similarly, as in the previous sessions, we don't go much deeper into the theoretical concept of all these. We will directly step into the problems and solve the diagram with all the relevant steps. So this comes the problem number 22. So here comes, draw locus of a point on the periphery of a circle which rolls on straight line path, and to take the circle diameter as 50 mm. So it's just telling us to make a locus of a point on the periphery of a circle which rolls on straight line path. So it's telling that there is a circle over in this way. So there is some point, there is some point on it. There is some point on it. If this circle not here, we will just assume that point over, see this is a circle, point over here, and this is line. If this circle rolls, if this circle rolls in this direction, so how the position of this point moves? So it just looks in this order. So this rolling of this circle, how the position of this point is changing. So it's just telling us to draw locus of a point on the periphery of a circle which rolls on straight line path. So taking the circle diameter as 50 mm. Okay, we'll see the thing. There are some solution steps to make the cycloid. So this is for a general method. So from center C, draw a horizontal line equal to pi d distance. See, this is a circle with a diameter of 50 mm. From center C, draw a horizontal line equal to pi d distance, nothing but the circumference. Now divide pi d distance into 8 number of equal parts and name them as C1, C2, C3, etc. Similarly to the circle, divide the circle also into 8 number of equal parts, and in clockwise direction after P, name 1, 2, 3 up to 8. See 1, 2, 3, 4, 5, 6, 7, 8. Similarly, divide the line also into 8 equal parts. name them as C1, C2, C3, so on to C8. From all these points on the circle, draw horizontal lines parallel to locus of C. So 1 to 7 is a parallel line, again 3 to 5, again from 4. So with a fixed distance C to P in compass, C1 as center, mark a point in horizontal line from 1 and name it P. See, with a fixed distance C to P in compass, mark a point on horizontal line from 1 and name it as P. Repeat this procedure from C2, C3, C4 up to C8 as centers. Mark the points as P2, P3, P4, P5 and so on to P8 on the horizontal line drawn from 2, 3, 4 to 8 respectively. Okay, now mark the points. That's the first point from C to P is in the dia on the compass, and C1 on the one line, C2 on the second line, C3 on the third line, C4 on the fourth, C5 again on fifth, C6 on sixth, C7 on seventh line, C8 again on the end. Now join all these points or name them firstly P1, P2, P3, P4, P5, P6, P7 and P8. So join all these points smoothly in order to obtain your required cycloid. So this is your locus of a point on the periphery of a circle which rolls on straight line path. So is it clear? Okay, we'll check it out again. Draw a circle of given dia. There is a path. Divide the circle into 8 equal parts. And name them in clockwise order 1 to 8. The 8th point is as P, and from the center C, nothing but the 2, 6 line. Extend the line from the center C to the value of pi d, nothing but the circumference of the circle. Divide this line again into 8 equal parts. And mark them as C1, C2 and so on to C8, and extend the horizontal lines from 1 passing through 7 and 3 passing through 5, similarly to 4. Now taking C to P as radius, measure the value in your compass and cut the arcs from C1, C2, C3 and so on to C8 so that it makes some points. So cut the arcs on the line C1 on the horizontal line 1, C2 on the line 2, C3 on the line 3 and so on to C8 on the line P. Now mark all the points of the intersections. This is C to P, this is C1 to 1, this is C2 to 2, C3 to 3 line, C4 to 4th line, C5 to 5th line and C6 to 6th line, C7 to 7 and C8 to 8th line, nothing but the P. Now join all the green colored points smoothly in order to obtain your required cycloid. Before that, mention the points P1, P2, P3 and so on to P8 and join them smoothly in order to obtain your required cycloid. So this is your general method to make the cycloid. Just take a minute and observe the diagram and note it down in your observation notes. Okay, we will move on to the next method. Superior trochoid but with a superior method. See the question. Draw locus of a point which is 5 mm away from the periphery of a circle which rolls on straight line path. So take the circle as 50 mm. So the die is same, but the locus of a point is 5 mm away from the periphery of a circle. So okay, we will see. Draw a circle of given dia and draw a horizontal lines from its center C of length pi d and divide it into 8 number of equal parts and name them as C1, C2, C3 and so on up to C8 and draw the circle by CP radius. As it is, first we will complete the first step. Take a circle of 50 mm dia, divide it into 8 equal parts. Before that, he is telling us to draw circle by CP radius, as in this case CP is larger than radius of circle. Now repeat steps as per the previous problem of cycloid by dividing this new circle into 8 number of equal parts and drawing lines from all these points parallel to locus of C and taking CP radius with different positions of C as center. Cut these lines and get different positions of P and join all the points smoothly. So this is your required curve called superior trochoid. So this P, mark your P of 5 mm away from the periphery of the circle. So this will be your 5 mm. This will be your 5 mm position. So mark your point 5 mm, point it as P and draw another circle which is higher than the original circle dia and divide this circle into 8 equal parts and mention the points in the order of clockwise. Same, from the center C, extend the line horizontally to the value of pi d, nothing but the circumference of the inner circle. Divide this again into 8 equal parts and mention them as C1, C2, C3 and so on up to C8. as mentioned in the previous slide. Now taking C to P as a radius and measuring your compass. Before that, extend the horizontal lines. From P, from 1 passing through 7, 2 passing through 6 is already existing, 3 passing through 5 and through 4. Now taking CP as the measurement in your compass and cut the arcs from C, C1, C2, C3 and so on. C towards P, C1 on the line 1, C2 on the line 2, C3 on the line 3 horizontal lines, C4 on 4, so on up to C8 on P line. See here, C1 on 1, C2 is already done, which is in the horizontal line, so it is overlapping. C3 on 3, C4 on 4, C5 on 5th line, C6 is again overlapping on the horizontal line, C7 on 7 and C8 on 8th line. Mark the points. So this is the position of your points. Now join all these points smoothly to get your superior trochoid. Before that, mention the names to these points P1, P2, P3 and so on up to P8. Now join all the points. So this is your curve which is called superior trochoid. Is it clear? Shall we see it again? Okay. Already I have set you. I'll just play for you this. Just overview it. Circle the line and a point 5 m away from the circle, and again the next circle over it. Divide this circle into 8 equal parts and mention them with the names in the clockwise order, and from the center C extend the horizontal line with the value of pi d, which is the circumference of the inner circle, and again divide it into 8 equal parts and mention the points as C1, C2, C3 and so on up to C8. Extend the horizontal lines from P and 1 passing through 7 and 3 passing through 5 and 4. Now marking C to P in your compass, cut the arcs from C1 to 1, C2 to 2 and so on to C8 to 8. And mark all the points clearly so that it is visible to you to draw your curve. So marking is finished, and mention them as P1, P2, P3 and so on up to P8. And join all the points smoothly, not through compass, with your hand, in order to obtain your required trochoid. So this is your required curve. So observe it. Just take a minute, observe it and make it in your observations. Okay, we'll move on to the next topic. inferior trochoid. So draw locus of a point 5 mm inside the periphery of a circle which rolls on a straight line path and take the circle diameter 50 mm. As in the previous, the point was 5 mm away from the circle and now the point is 5 mm inside the circle. See the steps. Draw the circle of given dia and draw a horizontal line from its center C of length pi d and divide it into 8 number of equal parts and name them C1, C2, C3 and so on up to C8. Draw a circle by CP radius as in the case of CP shorter than the radius of circle. Now repeat all the steps as per the previous problem cycloid by dividing this new circle into 8 number of equal parts and drawing lines from all these points parallel to locus of C. By taking CP as radius with different positions of C as center, got all the lines and different positions of P and join those in the curvature. So this curve is called your inferior trochoid. We'll see the diagram. Draw a circle of 50 mm dia and a surface line. There is a small circle over inside it which is 5 mm inside to the circle. Divide that circle into 8 equal parts and mention the points in the clockwise order, and from the center C extend the horizontal line at a distance of pi d and divide this line again into 8 equal parts. Mention these points as C1, C2, C3 and so on up to C8. Now taking C to P as the measurement in your compass. Before that, extend the horizontal lines from 1 passing through 7, firstly through P, and from 1 passing through 7 to C is already done, 3 passing through 5, 4. Now taking C to P as a measurement in your compass, mark the points from C, C1, C2 and so on up to C8 without disturbing your compass. Firstly from C, points at P and C1 on the horizontal line 1, C2 on 2, C3 on 3, C4 on 4, C5 on 5th line, C6 on 6th line, C7 on 7th, C8 on 8th, nothing but P. So these are the intersections. Mark all the points. These are the positions of the points and name them as P1, P2, P3 and so on up to P8. Join all these points smoothly to get your required curvature, nothing but a trochoid. So this is your required trochoid, inferior trochoid. Is it clear? Okay, we'll see it again. Draw a circle with a surface draw inner circle which is 5 mm inside to it, and divide the circle into 8 equal parts and name them as 1, 2, 3 and so on up to 8 in the clockwise order. Last point is P instead of 8, since we are moving that point. And now from the center C, extend the line, a horizontal line of the circumference of the given circle, which is pi d. Divide this line also in 8 equal parts and mention the points as C1, C2, C3 and so on up to C8. Now extend the horizontal lines from P and from 1 passing through 7 and 3 passing through 5 and from 4. Now taking C to P as your measurement in your compass, mark the arcs from C1 on the one line, C2 on the second, C3 on the third and so on up to C8 on the 8th, nothing but the P line. Now mark the points. The pointing should be in the correct order. Now join all these points smoothly. For that, mention the points as P1, P2 and so on up to P8. Now join all the points. So this is your required curve called inferior trochoid. So take a couple of minutes in order to make this diagram. Okay, we'll move on to the next method, which is epicycloid. See, draw a locus of a point on the periphery of a circle which rolls on a curved path. The take diameter of rolling circle of 50 mm and radius of directing circle the curved path as 75 mm. So this is an epicycloid. It's just telling us to draw locus of a point on the periphery of a circle which rolls on a curved path. So there are some steps involved in it. When smaller circle will roll on a larger circle for one revolution, it will cover the circumference distance on arc, and it will be decided by included arc angle theta. Now calculate theta by using your formula. As you all know that theta is equals to small r by capital R into 360 degrees. Now construct an angle theta with radius OC and draw an arc by taking O as center and OC as radius and form sector of angle theta, and divide this sector into 8 number of equal parts, angular parts, and from C onwards name them as C1, C2 and so on up to C8. And divide small circles, generating circles, nothing but also in 8 number of equal parts, and next to P in clockwise direction, and name them as 1, 2 and so on up to 8. Now with O as center, O2 as radius, now with O as center, O2 as radius, draw an arc in the sector, take O22, O23 and so on up to O28 distance with center O. Draw all concentric circles, arcs in the sector. Take fixed distance of C to P in your compass C1, in your compass, and C1 as center, cut arcs of 1 at P1. So repeat all these procedures and look at P2, P3 and so on up to P8 as in your cycloid, and join them by a smooth curves in order to obtain your epicycloid. Now we'll see the construction. This is a bigger radius of 75 mm. So okay, this is a higher radius of directing circle and a rolling circle of 50 mm dia, which is in your blue colored circle, which I have shown you in the arrow mark, which is nothing but a generating circle or a rolling circle. So now divide this circle into 8 number of equal parts and mention the points in the order of clockwise as 1, 2, 3 and so on up to 8. The 8th part is denoted as P, where this point has to be peripheral on a circle, which has to roll on a circle. Now the smaller circle one has the radius of 25 mm and it is denoted as small r. Now by O as center, with O to 4 as radius, and similarly from O to 3, O to 4, draw an arc at an angle of theta, and theta, the value of theta is denoted as small r by r into 360 degrees, where small r is radius of rolling circle and the capital R is radius of your directing circle. So the values will be 25 by 75 into 360 degrees. So that gets you a theta. So similarly you have to divide this angle into 8 number of equal parts. And as the same O to C as center, O as center, with O to C as radius, extend the arc and draw another rolling circle at the end of the arc. In the same order you need to extend the arcs from 3 by taking O as center, passing through 5, and same from 1 passing through 7, and similarly from 2 and so on. Now cut the arcs with O as center, O to 1 as radius, draw an arc in the sectors, take O2, O3, O4, O5 and so on up to O8. With center O, draw all concentric arcs in sectors. So these are the centers C1, C2, C3 and so on to C8. Now O to 1 as radius, draw an arc in the sector. Similarly O to 2 from C2, similarly from O to 3 from C3 and so on up to C8. So mark the points for all the intersections. And mention the names to the points as P1, P2, P3 and so on up to P8, and join all these points smoothly in order to obtain your epicycloid. So the pink colored curve is your epicycloid. We'll look into it again fastly. Firstly, draw a directing circle, nothing but the arc with the radius of 75 mm, which is a directing circle, and the rolling circle of 50 mm. And divide the circle into 8 equal parts and name them. 8th part as P, which is called rolling circle, and extend the arc at an angle of theta, which is nothing but small r by capital R into 360 degrees, and divide this arc into 8 equal parts. Draw a rolling circle at the end of the other arc and extend all the arcs from 3 to 1, 2, 3 and so on up to 5, 4, 5 to all the points. We have all the centers over here, which are C1, C2 and so on up to C8. Now taking O to 1 as radius, draw an arc in the sector. Similarly O to 2 and so on up to O to 8. And finally C2, measure the value of C2P in your compass, and C1 as center, cut the arcs in 1 and P1 similarly to the all, and mark the points and join the points smoothly to obtain your epicycloid. So this is your required epicycloid. Okay, now we will see the last method, hypocycloid. Draw locus of a point on the peripheral of a circle which rolls from the inside of a curved path. They take the diameter of the rolling circle as 50 and the same diametric circle as 75 mm. So there are some solution steps. Smaller circle is rolling here. Inside the larger circle, it has to rotate anti-clockwise to move ahead. Same step should be taken as in the case of epicycloid. Only changes is in numbering direction of 8, number of equal parts on the smaller circle. From next to be in the anti-clockwise direction. So name 1, 2, 3 and so on up to 8. Further all the steps are same as in the epicycloid. So then you will be obtaining a curve called hypocycloid. Okay, this is your directing circle. Instead of making the rolling circle on the outside, we are just making it in the inside. This is the difference. So and the other difference is dividing the circle into 8 equal parts and mention the points in the anti-clockwise order, and the rest is same. Same. See that in the anti-clockwise order. Same. C2 P as the radius on your compass. C1 cut the arc on the one line, C2 on the two. So all these intersections mark the points and extend the line with a smooth curve. This is your hypocycloid. We will see it again. Draw a radius of 75 mm, draw an arc of directing circle, and draw a rolling circle inside to it, and mark the points in the anti-clockwise order. Draw the value of theta at an angle of small r by r into 360 degrees as in the previous epicycloid. Divide that also into 8 equal parts. And also draw a circle at the end of the other arc. We have all the centers C1 up to C8. Divide the circle 8 equal parts, arc also into 8. But the difference in epi to hypocycloid, mark the points in anti-clockwise order. Previously it was in clockwise order, but here it is in anti-clockwise order, and the rest steps are same. Now measure C2P in your compass and mark the arcs at C1 as center on the one line, C2 as center on the second, C3 as center on the fourth, and so on up to C8. Join all these points smoothly in order to obtain your required hypocycloid. So this is the end of today's session. So I hope you have understood all the key points in it. So thank you one and all.